Okay, so problem 25.23 is explains to us that there is a 2.7 centimeter diameter parallel plate capacitor that has a 2.5 millimeter spacing. And the electric field strength inside the capacitor is 1.4 times 10 to the 5th volts per meter. And part A wants us to solve for the potential difference across the capacitor. So just a refresher on what exactly potential difference is. It's the work done per unit charge while moving the charge between 2 points in an electric field. Can also be thought as the change in potential energy per unit of charge between 2 points in an electric field. But notably, this is a similar to electric field. This is going to be a characteristic of the plate capacitor. So our potential difference across the capacitor is going to be independent from any kind of charge or anything like that. So the first thing that I did for this was went ahead and converted my units to uniform units, I guess. So you can see I did that with R and S, R being the radius of our circular plate capacitors, and S being that D, that distance between them. When I first did this, it can be kind of tricky to imagine this because for the problem, they don't give you a picture, you have to draw it. So just keep in mind that anytime it says diameter or radius or anything like that, you're going to have a circular situation. So going ahead and doing part A, we were given in the textbook that the potential difference for a parallel plate capacitor is going to be the electric field times the distance between the plates. So we have both of those already given to us. So all we have to do is plug them in, and it gives us a potential difference of 350 volts across the parallel plate capacitor. So that's part A. Part B is asking how much charge is on each plate. So we're going to be using the electric field equation from a few chapters ago, which shows for a parallel plate capacitor, it's going to be N over E naught, where N equals Q over A. And then rearranging everything, so we're solving for Q, we get Q equals the electric field times epsilon naught times A. And A is always going to be the area of one of the plates. So in this case, since it's circular, we're just going to have pi r squared. So now that we're here, we can just plug things in. So the charge on both of these plates is going to be 7.1 times 10 to the negative 10th coulombs. So one of them will have a positive of that, and the other will have a negative of that. So that's pretty much it for this problem. I think, honestly, the math isn't too tricky. The trickiest thing for me is the conceptually, understanding just what potential difference is. So I hope I explained that somewhat well. It can be tricky to correctly convert your units. Always be very, very careful with that. But yeah, that's pretty much it. Thank you for listening.